In this video, I want to talk about how to graph lines. And this is a topic that a lot of students have trouble with. And what you want to keep in mind when you're graphing lines is that all you really need is 2 points. And your graphing technique basically boils down to how you come up with those 2 points. Now, one of the techniques that you can use, and a lot of instructors will show you, is you can plug in points into your equation and come up with 2 points that way. But I have found this to be problematic in the past because, one, the students have no idea what they need to plug into the equation. And this is kind of intimidating for them. Two, it's easy to make a mistake when you're doing your calculations here, and that can throw off your graph and make the problem wrong for you. And three, you don't always get a nice, beautiful point that you can graph on your graphing paper that's easy to see or easy to do on a computer, for example. So I have a different technique that I like to do that I've been very successful with, and this is the way it goes. The first place you want to start off with is you take your line, and you start by solving for y. In terms of x. Now, most of the time, this has already been done for you. The problem will give you the line like this, where you've got y equals something x plus 5. And ideally, that's where you want to be. That's where you want to go. You want to get your line into slope-intercept form. Okay? When I say slope-intercept form, I mean that your line is going to be in the form y equals mx plus b. When it's in slope-intercept form like this, it's really easy to graph it, especially with the technique that I'm about to show you. So the line that we have right here is y equals 4/3 x plus 5, and it's already in slope-intercept form. And when you're looking at a line in slope-intercept form, the part in front of your x right here, that's your slope. And the constant, the b term, that's going to tell you your y-intercept. Okay? So our next step in this process is to identify the slope and the y-intercept. So in this case, my slope is going to be 4/3. And my y-intercept is going to be the point 0, 5. So the x-coordinate of this point is always going to be 0 for the y-intercept. And we may talk about that later. All right. Once you have your slope and your y-intercept identified, our third step is to use that information to find the second point. Okay. Now, what a lot of people will do here is they'll start their y-intercept on the graph and they'll move over 3 and they'll move up 4 because this is our rise and this is our run. And what I'm going to do here is going to be a little bit different. What I'm going to do is, instead of trying to count on the graph, which I have trouble with sometimes, what I'm going to do is I'm going to add the bottom of my slope to my x coordinate and the top of my slope to my y coordinate. So I'm going to find my second point algebraically as opposed to visually. So over here, I'm going to add 3 to x, I'm going to add 4 to y, and that's going to give me my second point. So my second point is going to be 3, 9. And these are the 2 points I'm going to need for my graph. So when I go to graph my equation, I'm going to start at my y-intercept, which is 1, 2, 3, 4, 5, 0, 5. And then I'm going to go to my second point, which is going to be 3, 9. So here's 3, and then that's 9. So right here. And that's going to complete my line. So in the next video, we're going to do another example with this, with different numbers, and we'll probably go through a couple of examples.